Somewhere over the California desert in October of 2025, a machine took off with no one inside it. No pilot, no cockpit, no human heartbeat anywhere on board. It climbed, it maneuvered, it made decisions. And every single one of those decisions was its own. 9 months later, on June 17, 2026, the United States Air Force did something it has never done in the entire history of American air power. It signed a contract to mass produce that machine for war. Not a test. Not a demonstration. Production order. For an aircraft designed, from the very first line of code, to fly into combat, absorb the first missile, take the first radar lock, and if necessary, die so that the human flying beside it does not have to. They are called collaborative combat aircraft. The pilots who will fly with them call them something simpler. Loyal wingmen. And in the space of 18 months, they went from an experimental concept to a signed, funded 4 months ahead of schedule production program. Because the United States Air Force has quietly concluded something terrifying and true. The next war in the sky will not be won by the best pilot. It will be won by the pilot with the most machines willing to die first. This is the story of the aircraft that is rewriting the oldest rule in aerial combat. This is the story of the robot wingman learning how to kill. For 80 years, air combat has run on a single, unbroken assumption. One aircraft, one pilot, one radar, one decision-maker, entirely alone in the sky at the moment it matters most. Every doctrine, every training program, every fighter ever built was designed around the reality that a human being sits inside the machine, and that human being's life is the single most expensive, most irreplaceable asset on the battlefield. That assumption is now the single greatest vulnerability in modern air power. Because a modern integrated air defense system, the kind China has spent 2 decades building across its coastline, layered with long-range radar, surface-to-air missile batteries, and fighters guided by satellite-linked targeting data, does not need to outfly an American pilot. It only needs to force that pilot into range of enough sensors for long enough that the odds eventually catch up. Every 5th-generation fighter America has, the F-22, the F-35, the F-47 now entering testing, is extraordinarily capable and extraordinarily finite. There will never be enough of them, and every single one carries a human being whose loss is not just a tactical setback, it is a national wound. The Pentagon's own wargaming scenarios for a potential conflict in the Pacific have quietly delivered the same brutal conclusion for years. In a high-intensity fight against a peer adversary, the United States would not simply need better aircraft. It would need more aircraft than its current fighter fleet, its current pilot pipeline, and its current defense budget could physically produce in time. That is not a problem stealth coatings can solve. That is a problem of raw, attritable mass, and building more manned fighters at roughly $100 million in years of pilot training per aircraft was never going to close that gap fast enough. So the Air Force asked a different question entirely. What if the aircraft absorbing the risk didn't need to come home? What if it didn't need a pilot at all? The answer began quietly, buried inside contract announcements most people never noticed. In January of 2024, the Air Force handed contracts to 5 of America's most capable aerospace companies: Anduril, Boeing, General Atomics, Lockheed Martin, and Northrop Grumman, and asked them to design something that had never really existed before. A fighter-sized aircraft that could fly, fight, and make tactical decisions without a person inside it, cheap enough to build in the hundreds, and fast enough to keep pace with a manned fighter in a live engagement. By April, the field had narrowed to 2. Anduril, a company barely a decade old that had built its reputation on autonomous defense software rather than traditional airframes, and General Atomics, the veteran drone manufacturer behind the Predator and Reaper. Both were ordered to build production representative test aircraft. Both understood exactly what was at stake. What happened next moved at a pace that stunned even people inside the defense industry. Anduril's aircraft, a sleek jet-powered design called Fury, made its first flight in October of 2025. General Atomics based its entry, eventually named Dark Merlin, on an earlier experimental airframe, and by early 2026 had achieved semi-autonomous flight using advanced mission autonomy software from RTX's Collins Aerospace division. General Atomics would later describe the sprint from contract award to first flight as one of the fastest rollouts of a new fighter aircraft in history, at just 15 months. There were setbacks. Earlier this year, a General Atomics prototype crashed during testing after an autopilot miscalculation involving the aircraft's weight and center of gravity. It was grounded for roughly a month while engineers rewrote the flight software, then it flew again. The Air Force later confirmed explicitly that the crash played no role in the decision that followed, because it understood something the public conversation around military drones almost never captures. This is not remote-controlled model airplane technology. This is genuine test and failure engineering on a program moving so fast that setbacks measured in weeks, not years, are treated as proof the pace is working. Then on June 17, 2026, came the moment that changed everything. The Air Force awarded full engineering, manufacturing, and production contracts to both companies simultaneously. General Atomics for the newly redesignated FQ-42A and Durrell for the FQ-44A, 4 months ahead of the Pentagon's own internal schedule. The Air Force is now committed to fielding at least 150 of these aircraft by the end of the decade, with an eventual program of record aiming for 1,000. 1,000 unmanned fighter-class aircraft entering the American arsenal on a timeline measured in years, not generations. Here is what should genuinely unsettle a rival war planner reading these specifications for the first time. According to Endural's own Vice President for Autonomous Air Power, the FQ-44 Fury has a ferry range sufficient to deploy anywhere on Earth under its own power. It can take off and land on a short, austere runway, the kind a manned fighter could never operate from safely. Its combat radius significantly exceeds that of current crewed fighters, and it has the speed to keep pace with them in a fight rather than trailing behind as a slower support asset. It has already completed captive carry testing with live configuration AIM-100 20 AMRAAM air-to-air missiles slung beneath its wings, inert for now, but mounted, tested, and validated for the exact weapon that shoots down enemy fighters at beyond visual range, and the cost. The Air Force has stated its explicit target is for each CCA to cost less than 1/3 the price of a single F-35, and acquisition officials say the program is currently beating that goal. Do the arithmetic on that for a moment. For the production cost of one crewed $100 million class fighter, with one irreplaceable pilot inside it, the United States Air Force can field 3 or more autonomous aircraft that carry real weapons, fly real combat radii, and never once put a human life at risk on the first pass into contested airspace. But the true technical revolution isn't the airframe. It's the decision the Air Force made about how to build the brain that flies it. In a strategy officials call software sold separately, the Pentagon deliberately decoupled the physical aircraft from the artificial intelligence that controls it. 6 different companies: Anduril, General Atomics, Lockheed Martin, Northrop Grumman, RTX Collins Aerospace, and Shield AI are locked into an ongoing 6-year competition specifically to build and continuously improve the autonomy software these aircraft will run. Under the current arrangement, a company is only paid its full licensing fee if its software actually proves it can deliver combat capability that real warfighters validate as useful. That means the intelligence flying these machines will never be allowed to stagnate. It is designed to be replaced by something smarter the moment something smarter exists. That is the detail that should genuinely terrify anyone trying to war game against this system. It's not simply that America will have 1,000 additional combat aircraft. It's that the software commanding those aircraft is engineered to be in a perpetual competitive arms race against itself. 6 of the most capable technology and defense companies on the planet, permanently incentivized to make these machines faster, sharper, and more lethal, indefinitely, with no final version ever being declared finished. Think, for a moment, about what a single American fighter pilot's cockpit will look like within the next few years. Instead of one radar, one missile load, and one set of eyes scanning the sky, that pilot will sit at the center of a small formation of autonomous aircraft. Machines that can fan out ahead, absorb the first radar contact, present themselves as targets, fire the first shot, and feed sensor data back before an enemy has even confirmed how many actual threats it's facing. A rival aircraft entering that engagement will not be fighting one American fighter. It will be fighting a formation in which it cannot immediately tell which contact is the irreplaceable asset and which one is expendable by design. That uncertainty is not a side effect. It is the entire point. A defense planner in Beijing or Moscow now has to build an air defense strategy around a scenario where the United States can afford to lose aircraft in a fight. dozens of them, hundreds of them, without losing a single pilot, without a single grieving family, without a single political cost back home. Attrition, the oldest and most reliable weapon any adversary has ever held over American air power, is being quietly, deliberately engineered out of the equation, and the timeline compounds the pressure. These contracts were awarded 4 months ahead of schedule. First flights happen in a fraction of the time historically required for a new fighter-class aircraft. Production is already underway while the autonomy competition continues in parallel, meaning the aircraft entering service in 2027 will not be the final version. They will be continuously upgraded platforms, receiving smarter software as the six-company competition produces better results for years after they first reach a flight line. No rival nation currently fielding a comparable program can point to a production contract, a flight-tested airframe, and a live-fire weapons integration test all completed on this kind of compressed timeline. The gap this creates is not measured only in aircraft numbers. It is measured in how confidently an adversary can plan a war it does not know in real time, how many autonomous threats it will actually be facing. There is an old, uncomfortable truth at the center of every air war ever fought, that the side willing to lose more, to spend more lives and more machines to win the exchange, has always held a terrible kind of leverage. The Collaborative Combat Aircraft Program is the United States Air Force's answer to that truth, and it is a colder, more calculated answer than any recruiting poster or airshow flyover has ever suggested. It does not eliminate risk from air combat. It reallocates it deliberately, away from the humans who cannot be replaced and onto the machines that were built from their very first blueprint to be exactly that. Somewhere in Ohio at a new factory Enduro built specifically for this program, and somewhere in California on a production line General Atomics says is already well underway. The aircraft that will fly beside America's next generation of fighter pilots are being built right now, 4 months ahead of a schedule that was already considered aggressive. Within a few years, a young pilot climbing into an F-35 or an F-47 will look at a formation display and see not one wingman but several. None of them afraid, none of them tired, none of them carrying a family waiting at home, all of them there for exactly one purpose, to make sure the human in that cockpit comes home. That is the quiet, unglamorous revolution unfolding right now over the deserts of California and Ohio. Not a single dramatic weapon. 1,000 loyal machines learning, in real time, how to fight and how to die so that someone else doesn't have to. The robot wingmen are no longer a concept on a whiteboard. They have a contract, a production line, and a delivery date. And the next time an American fighter pilot goes into contested airspace, they will not be going in alone.